Welcome to Podcast Learn and Fun. Let's start today's journey of learning. Ever notice how some things in life just seem to happen, randomly, unpredictably? It's like taking a trip and having no clue what the next stop will be.
Right. And it's actually pretty fascinating how this randomness that we see, we can describe it mathematically.
Oh, okay. Interesting. So, how does a walk become random, mathematically? I'm kind of picturing someone just, wandering around with no real direction.
Yeah. Well, imagine you're walking on this path, and to decide each step, you flip a coin. Heads, you go right, tails, you go left. So each step doesn't depend on the last one at all. It's all about that coin flip.
So it's like those choose-your-own-adventure books, but with a coin deciding every turn.
Exactly. And this might sound pretty basic, but it actually helps us understand some big concepts. For instance, even though every single step is random, we can actually calculate the chances of ending up in a specific spot after a certain number of steps.
So even with all that randomness, there's a way to figure out where you might end up.
Yeah, precisely. And that's where this idea of variance comes in. Basically, variance measures how spread out all those possible ending positions are, and the more steps you take, the more spread out those positions get.
So the longer you wander around randomly, the less sure you are about where you'll actually end up. That makes sense, but it's kind of cool that we can measure that uncertainty, with math.
Yeah. And get this, understanding random walks and their variance and how those probabilities are spread out, it's actually super important in all sorts of fields.
Wait, really? So it's more than just some, theory? Where does this pop up in the real world?
Okay, well, picture those little dust particles dancing in a sunbeam. Looks chaotic, right? But that's Brownian motion, and it's explained perfectly by random walks. Each particle is constantly bunking into even tinier molecules, making it jiggle around in random directions, just like our coin flipping walker.
Wow. So even something as random as dust in a sunbeam has, a hidden order to it, and we can understand it through random walks.
Yeah. Exactly. And that's just one example. We'll get into more of these fascinating applications after a quick break.
That dust particle thing, that was a really good example. I never thought about it like that before. It's kind of wild that we can explain something so random using math.
Yeah, it really shows you just how powerful math can be when it comes to finding those hidden patterns in the world. And with random walks, it gets even more interesting when we look at how those patterns actually change over time.
Oh, okay. So it's not just about where you end up, it's about how you got there.
Exactly. Like we're tracking the whole journey, not just the destination. And to do that, we use something called a probability distribution.
Probability distribution, huh? Sounds a little complicated. Can you maybe explain that in simpler terms?
Sure. Think back to our coin flip walker. After, say, 10 steps, they could be in all sorts of different spots, right? Some spots are going to be more likely than others, just depending on how those coin flips went. A probability distribution basically maps out all those possible positions and tells us how likely it is to end up at each one.
So it's like a map showing all the different paths, and it highlights the ones that are more likely to be taken.
That's a great way to put it. And there's this really cool way to visualize it. Imagine a pachinko machine. Each ball represents a step in the random walk, and those little pins represent the coin flip choices. So how the balls are spread out at the bottom, piled up in those different slots, that shows you the probability of ending up in each position.
Oh, okay, I get it now. So some slots would have way more balls, meaning it's more likely to end up there.
Exactly. And with simple random walks, like our coin flip example, this distribution ends up looking like something you might recognize. The bell curve.
Oh, yeah, the bell curve. That's the most famous thing in statistics, right? Yeah. What's it doing here?
Well, it shows this really deep connection between randomness and order. See, as you take more and more steps in a random walk, that probability distribution, which might start off kind of jagged and all over the place, it starts to smooth out and take that classic bell shape.
So even though every individual step is totally random, the overall pattern, like where you're likely to end up, that starts to become more predictable.
Yeah, exactly. It's just like flipping a coin. You can't predict a single toss, but flip it 1,000 times, and you can be pretty sure you'll get close to 50 heads and tails.
That's pretty mind-blowing when you think about it. So basically, we can use this knowledge about probability distributions and the bell curve to analyze all kinds of random walks in different situations.
Absolutely. It's super useful for understanding how random events actually play out in real life. And it gets even more interesting when we move beyond just walking in a straight line. Imagine our walker can now move on a two-dimensional plane, like a chessboard.
Oh, wow. So instead of just left or right, they can go up, down, diagonally.
Yeah.
That adds a lot more options.
It definitely does. And while the math gets a bit more complex, those basic random walk principles, they still apply.
I bet those two-dimensional random walks can explain a lot more stuff in the real world.
You're right. Think about, for example, how a contagious disease might spread. Each infected person can move around in all sorts of directions, maybe bumping into other people and passing on the illness. That movement pattern can be modeled as a 2D random walk.
Wow, so random walks can even help us understand how diseases spread. That's crazy.
And it's not just diseases. Think about animals searching for food. They often move in these seemingly random patterns, exploring their environment to find those resources. That, too, can be seen as a type of two-dimensional random walk.
So from dust particles to diseases to animals, it's like random walks are everywhere.
You got it. And we haven't even talked about three-dimensional random walks, which can be used to model things like how molecules move in gas or how pollutants spread in the air.
Wow, my brain is a little overloaded. It's amazing how something that starts with a simple coin flip can have so many applications.
It really is. It shows you how everything is connected and how even a simple mathematical model can help us understand the world around us so much better. And you know what? We've only just scratched the surface of this amazing concept.
I can't wait to see what other surprises random walks have in store. But I think I need a moment to process all of this.
Yeah, let's take a second to let all that information sink in. When we come back, we'll dive into some even more incredible applications of random walks.
Okay, I think I'm ready to keep exploring those random walks. What other cool applications are out there?
All right, let's zoom in, way in. Like from the big stuff we've been talking about down to the microscopic world, think about those super complex molecules. You know, the ones that make up life, DNA, proteins, all that. They're not just sitting still, they're folding and twisting into these crazy shapes, and those shapes determine what they do.
Okay, yeah, but where do random walks come in? Is it like our DNA is actually doing a random walk or something?
Well, not exactly. But the way those long chain-like molecules, contort and move around in space, that can actually be modeled as a 3D random walk. Each link in the chain is kind of flexible, it can rotate and bend, just like our coin flip walker taking steps in different directions.
So you're saying the shape of those molecules, the ones that make life possible, is influenced by like random movements. That's pretty wild.
Yeah, it really shows how randomness can create complexity and diversity.
Yeah.
And understanding this is super important for scientists who are, say, designing new drugs or new materials. By understanding how these molecules behave, they can design drugs to interact with them in specific ways or make new materials with certain properties.
So random walks are helping us figure out the secrets of life itself and create new technologies. Pretty amazing stuff.
It really is. And now let's shift gears completely and go from the microscopic world to the vastness of space. Believe it or not, random walks can help us understand how galaxies actually cluster together.
Wait, hold on. Galaxies are doing a random walk. How does that even work?
Okay, imagine the early universe, just after the Big Bang. Matter wasn't spread out perfectly evenly. There were these tiny little differences in density. And over billions of years, gravity took over, pulling matter towards those denser spots and eventually forming galaxies.
So those tiny differences, those were like the starting points for our random walkers.
Exactly. And the way those density differences grew over time, leading to the structure of the universe we see today, it can be modeled as a kind of cosmic random walk.
So random walks are happening at the smallest level with molecules and also at the biggest level with galaxies. My mind is blown.
It just shows how powerful math can be, connecting things that seem completely different. And you know what? There's another example a lot closer to home that you probably use every day. Those search algorithms that power the internet, the ones that help you find stuff online, they rely on random walks too.
Seriously, every time I Google something, there's a random walk happening behind the scenes.
Yep. These algorithms basically simulate someone randomly clicking links and browsing the web. The more a web page is visited during these simulated random walks, the higher it ranks in the search results.
Wow, I had no clue.
So,
Random walks are a part of our digital lives too. It's amazing how something that starts with just flipping a coin can be used in so many different ways.
it really is. It shows that randomness isn't just about chaos and unpredictability. It can create order, complexity, even beauty. And by understanding how random walks work, we can understand so much more about our world, from the tiniest molecules to the vast universe.
Well, that was an incredible journey into the world of random walks. I'm definitely seeing things differently now. Thanks for all the insights.
It was my pleasure. Hopefully this has made you a little more curious about those hidden patterns and connections that shape everything around us.
Thank you for listening to Podcast Learn and Fun. If you like our videos, please subscribe, click the like button, comment, and share. See you next time.